Hello everybody, this is Jeff Janess and welcome to our 6th lab exercise demonstrating the ArcGIS hydrology tools. Now here we're going to learn how to generate a flow accumulation raster. This is essentially the size of the watershed or catchment area or drainage basin that drains into every cell on the landscape, except the units are not traditional area values like hectares or acres, but rather the number of cells that drain into each cell. Now if the cell's at the top of a ridge, then the number of cells is going to be 0. Cells that are at the exact bottom of a drainage, directly in the flow path, tend to have flow accumulation values that are orders of magnitude larger than their neighbors. We get to take advantage of this extreme difference in flow accumulation values to identify where the actual flow path is. Now, flow accumulation rasters are generated from flow direction rasters, and much like the incorrect watershed raster you generated in lab exercise 2, accurate flow accumulation rasters depend on flow direction rasters that are generated from filled DEMs. If you fail to fill your DEM before calculating your flow direction raster, then everything that comes out of that is going to be bad. And in this case, we'd get flow accumulations that only show accumulation over short stretches of the landscape, in between sinks on the landscape. Okay, let's get started. First off, we have to make sure we have the correct flow direction raster available in our map. I have it right here. Then we open up the flow accumulation tool. That's in Analysis, Tools, Flow Accumulation. Here it is. The input flow direction is here. We're going to call the output flow accumulation raster just flow accumulation. We don't need a weight raster. The output data type float is fine, and we have to specify that the flow direction that we're using was generated using the D8 method, and all this is accurate. Just hit run. And here we go. It has generated it successfully. Now, you might notice that the flow accumulation raster doesn't look real impressive right off. It looks like it's mostly black with maybe a couple little white spots, and you got to wonder if it was doing it right. But this goes back to what I was mentioning earlier, that the cells that are in the drainage itself have just much higher values than all their neighbors. And that's kind of what we're seeing here. And we can make it jump out a little better if we symbolize using a different method. If we just go here to symbology, we could pick, rather than percent clip, if we chose histogram equalize, it makes it jump out a little bit better, so we'll do that. So that makes it pop out a little bit. We can come into Picture Canyon and take a look at it here. And you can see pretty clearly here that there is a nice drainage that goes right through the middle of the Picture Canyon Preserve. Now let's take a look at what some of these values are. I'm going to zoom in even better so we can really make sure we're getting cells that are in the drainage and out of the drainage. Okay, I'm going to use the Explorer tool. It's in the Map tab. Hit the Explorer. This just lets us click on a cell and see the value. I'm going to just click on this one here. And this says that we have a flow accumulation of 87. And it says stretch.pixel value. Don't worry about the stretch. I don't know why they put that in. That's only telling you that it's currently symbolized using a stretch symbology. All we really care about is the pixel value being 87. That means there are 87 cells that drain into whatever cell we clicked on. So 87 over here, what happens if we click in here that's right in the drainage? This cell has 14,000 cells. This cell right here has 386,000 cells. And right next to that, 5 cells. So dramatic differences inside and outside the drainage. Okay, now just to practice what we're learning in lab exercise 1, if I wanted to know the area in acres, say on this cell right here, this cell has 47 cells draining into it. What is the acreage of the watershed that drains into that cell? Well, if you remember from lab exercise 1, we can just use the Windows calculator to figure this out. So we just bring up our calculator. We multiply the cell size X times the cell size Y Tells us it's 788 square meters per cell. That ought to look familiar. Multiply it by the conversion factor. So 0.19 acres per cell. Multiply that times the number of cells, which is 47. And there's 9.16 acres that drain into that spot that we clicked on. All right, that's all there is to that. Thanks so much, everybody.